axial flux motor. Really significant advantages in efficiency, weight, size, and mass because of these very particular segments and the way we design them.
No one saw it coming. For years, it was whispered about in closed circles, rumours of a revolutionary motor design that could change the rules of the electric vehicle game. A technology so advanced, so disruptive, that it sounded more like science fiction than engineering. But now, it's real. Mercedes has officially pulled back the curtain on its long-secret YASA Flux Motor, and the global auto industry is in shock. While companies like Tesla and BYD have dominated the electric vehicle headlines with flashy updates, battery tweaks, and incremental efficiency gains, Mercedes was playing an entirely different game. And now, they've just flipped the board. The YASA Flux Motor isn't just a new powertrain, it's a complete reinvention of how electric motors work. With a radically different design philosophy and groundbreaking performance metrics, this engine isn't merely an upgrade, it's a leap forward. Think lighter weight, think dramatically higher efficiency, think unprecedented torque and acceleration, all packed into a motor so compact, 2 people can carry it. Real quick, if you're into videos that cut through the noise and break things down clearly, go ahead and hit that like button. It helps more people find this, and if you're not subscribed yet, now's a good time. We've got more deep dives coming your way. Also, drop a comment and let me know what you think. I'd love to hear your take. Now onto the video. This is more than just a technological achievement. This is a corporate power play, and it's sending ripples through boardrooms from Palo Alto to Shenzhen. Tesla, once considered the unchallenged king of EV innovation, is now staring down a rival that's not just catching up, but threatening to overtake. BYD, the world's most prolific EV maker by volume, suddenly looks vulnerable in a game it thought it had already won. But what exactly makes the YASA Flux Motor so dangerous to the status quo? Why did Mercedes keep it under wraps for so long? And most importantly, how is this breakthrough going to affect you, the consumer, and the future of mobility as we know it? In this video, we're breaking down the full story. We'll take you behind the scenes into the secretive development of this motor, uncover how it works, reveal what Mercedes has already proven in real-world testing, and expose why the world's biggest EV players are scrambling to respond. Because this isn't just about one motor, it's about who controls the future of transportation. And right now, Mercedes is making a strong claim to the throne. To understand the magnitude of the YASA Flux Motor reveal, you need to go back, way back, to 2021. At the time, Mercedes-Benz quietly acquired a little-known British startup named YASA. Barely a blip in the headlines. Most analysts wrote it off as a routine acquisition, the kind of R&D investment big automakers make all the time to pad their innovation portfolios. But this wasn't routine. It was strategic. It was surgical, and it was the beginning of a plan that would unfold in near-total secrecy for the next several years. YASA, which stands for Yokeless and Segmented Armature, had been working on a radically different type of electric motor, one based on axial flux technology. While most of the world's electric motors use a radial flow design, more on that later, YASA believed axial flux held the key to unlocking the next generation of electric propulsion. Their prototypes were promising, lightweight, compact, and extremely efficient. But they lacked the resources to scale. Enter Mercedes. When Mercedes took over, they made a bold and unusual decision. Silence. No press releases, no media buzz, no flashy EV concept cars at auto shows. Internally, Mercedes gave YASA something rare, complete freedom. The directive was simple. Take your time, perfect the technology, and don't worry about hype. Just make it work. For years, the project flew under the radar. Even within Mercedes-Benz's own dealer networks and regional offices, information about the YASA project was scarce. Engineers operated on a need-to-know basis. Testing occurred in private labs and off-the-grid tracks. When occasional rumours did surface online, typically from patent filings or cryptic job listings, they were quickly dismissed as vaporware. But behind the scenes, the work was relentless. Early tests of the flux motor exposed flaws, overheating, magnetic plate failures, durability concerns. But with each failure came a fix. Each iteration brought the team closer. Mercedes and YASA engineers worked hand in hand, solving complex thermal management issues, refining magnet configurations, and enhancing winding techniques to improve compactness and reliability. By 2022, the first viable prototype emerged. Still not ready for the world, but good enough for real-world evaluation. It was quietly slotted into a Mercedes EQS test platform. Engineers noted a 70-kilogram drop in weight and a 12% improvement in range, without changing the battery. And yet, even then, Mercedes didn't speak a word. The silence was calculated. Mercedes knew that if they spoke too soon, competitors like Tesla or BYD might catch wind and accelerate their own development timelines. They weren't just developing a product, they were preparing a strategic weapon. And when the moment came, they wanted the world to be unprepared. It's a strategy that seems to have paid off, because when Mercedes finally went public with the YASA Flux Motor in early 2024, the reaction wasn't just excitement, it was disbelief. Industry analysts scrambled to understand how such a mature and ready-for-production technology could have been developed entirely off the radar. EV forums lit up with comparisons. Investors began shifting their outlook on the EV landscape. And Tesla? Silent, caught off guard. BYD? Watching closely. The question now wasn't whether Flux technology would work, it was when it would reach the road and who would be left behind when it did. To truly grasp the significance of what Mercedes has accomplished, you need to understand how electric motors actually work and why the YASA Flux Motor is such a dramatic departure from the norm. For over a decade, electric vehicles have relied on a motor design called the radial flux motor. It's a solid, reliable design, used by industry giants like Tesla, BYD, and Ford. In a radial motor, the magnetic field and electrical current flow in a circular direction outward from the centre. Picture a bicycle wheel, where the movement and torque are generated by the rotating rim. It works, but it has a major downside: energy loss. Radial motors tend to generate a lot of heat. The larger the motor, the more intense the heat dissipation challenge. As a result, cooling systems must be added, increasing the overall weight and complexity of the vehicle. Plus, the efficiency of energy conversion is typically capped at around 90% and 93%, with the rest lost as heat. Enter axial flux technology, the core of the YASA Flux Motor. Instead of power flowing outward like in a radial motor, axial flux works like a fan. The magnetic field and current flow parallel to the axis of rotation, hence the name. Think of a ceiling fan spinning. The blades move in a flat, disc-like motion. This design significantly reduces wasted energy and delivers a major boost in efficiency and torque density. Here's the astonishing part. With axial flux, Mercedes can achieve the same or greater power output with a motor that's up to 50% smaller and 60% lighter. The typical EV motor weighs around 100 kilograms. The YASA Flux Motor, around 30-40 kilograms. That weight difference alone translates into immediate benefits: lower overall vehicle mass, improved handling, and, most critically, increased battery range. But the advantages don't stop there. The YASA Flux Motor boasts efficiency levels as high as 97%, meaning nearly every bit of energy from the battery is converted into usable power. That means longer drives, faster acceleration, and dramatically less strain on the vehicle's thermal systems. It runs cooler, lasts longer, and performs better under stress. Another key advantage? Power density. The flux motor produces more torque per cubic centimetre than any standard radial motor. This means high performance in a compact package, ideal for luxury performance vehicles and agile urban EVs alike. And there's a secret sauce. Mercedes and YASA developed a proprietary combination of magnetic materials and segmented armature design that makes their axial motor not only efficient but also easier to mass produce. It's not just a science experiment, it's manufacturing ready. That's critical because many startups have dabbled in axial flux before but failed to deliver something scalable. Mercedes has succeeded where others failed. The flexibility of the flux design also opens new doors in vehicle architecture. Because the motor is smaller and flatter, it can be mounted in ways that were previously impractical. Front, rear, even in the wheels themselves, it gives engineers newfound freedom to reshape EV interiors, chassis, and aerodynamics. In short, the YASA Flux Motor represents a complete rethinking of electric propulsion. It's not just an improvement, it's a redefinition. And the fact that it's real, tested, and on the brink of production is what makes this development so seismic. Mercedes hasn't just created a better motor, they've set a new benchmark, one that other automakers now have to meet or risk falling behind. For years, Tesla has been the undisputed leader in electric vehicle innovation. They pioneered battery integration, over-the-air updates, autonomous driving features, and motor performance that stunned the auto world. BYD, on the other hand, dominated through a different strategy: scale and affordability. With a focus on low-cost production and mass-market appeal, BYD rapidly became the top-selling EV brand in China and a major global force. But now, Both are facing a storm they didn't see coming. The YASA Flux Motor isn't just an innovation. It's a direct threat to the foundation of their business models. Let's start with Tesla. Their current motors, though high-performing, still rely on the radial flux architecture. To achieve the kind of acceleration and range Tesla is known for, they've had to engineer elaborate cooling systems, beef up their battery packs, and optimize weight distribution. It works, but it's an increasingly heavy and expensive solution. Now imagine this. Mercedes offers similar or better performance, but with a motor half the weight, fewer cooling requirements, and higher efficiency. Suddenly, Tesla's core advantage, range and speed, no longer feels so unique. There's also a cost implication. Tesla's motors aren't cheap. With Flux motors, Mercedes could eventually build high-performance EVs at a lower cost because the motor itself is simpler to assemble and uses fewer complex parts. That's not just a performance edge, it's an economic one. And the nightmare doesn't end there. Tesla's production lines, supply chains, and patents are built around radial motor architecture. Switching to axial flux isn't a matter of copying and pasting, it's a massive redesign. It requires new materials, manufacturing tools, and years of R&D. Tesla can respond, but it'll take time. Time Mercedes already used to get ahead. Now, let's talk about BYD. Their strategy hinges on being affordable and reliable. They dominate budget EVs in emerging markets, but their motors? Still radial. Their edge in pricing might evaporate if Mercedes brings the Flux motor to mid-range and budget models. And make no mistake, that's part of the plan. Flux technology allows for simplification. Fewer moving parts, less heat, smaller size. All of this reduces cost per unit. If Mercedes can scale production and push Flux-powered cars into the mass market, BYD is in trouble. Because at that point, consumers would get more range, more performance, and the Mercedes brand, all at BYD-level prices. The result? A race against time. Tesla is likely already scrambling to develop a rival axial motor. BYD is no doubt investing in R&D to keep up. Other automakers like Hyundai, Ford, and Volkswagen are likely doing the same, but they all face the same problem. Mercedes got a head start, and they kept their advantage hidden for years. Meanwhile, Mercedes has hinted that key Flux motor patents may be protected, potentially giving them a temporary monopoly on the design. If that happens, competitors may be forced to license the tech, or spend billions trying to engineer around it. So where does that leave Tesla and BYD? In a defensive position. Their dominance is being challenged not with hype or gimmicks, but with raw, proven engineering. And in the EV game, that's the kind of disruption that can reshape the entire leaderboard. Talk is cheap in the automotive world, concepts are everywhere. But execution, that's what separates the dreamers from the disruptors. And Mercedes has already done what many claimed was impossible. They built, tested, and proved the YASA Flux Motor works, not just in the lab, but on real roads, in real cars, under real stress. Let's start with their internal testing. Shortly after acquiring YASA in 2021, Mercedes began closed-door prototyping. Early versions of the Flux motor were tested on dynamometers, measuring torque and power output across varying loads. Engineers pushed the motor to thermal extremes, trying to induce failure. The goal wasn't to prove it worked, it was to see where it broke. Over time, the improvements were staggering. By 2022, a refined Flux motor prototype was integrated into a testbed version of the Mercedes EQS, their luxury flagship EV. The results stunned even the engineers. The car dropped 70 kilograms in weight, thanks to the lighter motor. Range increased by 12%, using the exact same battery. Acceleration improved significantly due to better torque response. And most importantly, the motor ran cool, even under load. But Mercedes didn't stop there. Next, they outfitted their AMG EQE and EQS models with the Flux motor, vehicles known for high-performance benchmarks. In controlled tests, the new powertrain shaved 0.7 seconds off the 0 to 100 km/h time, a massive gain in a world where every millisecond counts. Then came the stress test, a 24-hour continuous run on a closed track, no pauses, no shortcuts. Engineers monitored heat, energy output, and wear. Not only did the motor maintain stable performance for the full duration, but it showed no signs of thermal fatigue, a known Achilles' heel for radial motors under extended use. The success didn't end with sedans. Mercedes moved to heavier platforms, their EQ SUVs. SUVs demand more torque due to their weight, and traditional EV motors struggle to balance power with efficiency. But the Flux motor delivered smoother acceleration, increased range, and a lighter chassis. Finally, in early 2024, Mercedes went public. In a private demo attended by media and insiders, the EQS Flux Edition hit 0-100 km in just 3.2 seconds. Onlookers described the ride as supercar-like, with razor-sharp response and silent, powerful acceleration. For context, that's faster than many gasoline-powered AMG models. And to seal the deal, Mercedes conducted a side-by-side test on a racetrack, a traditional EQE versus the Flux EQE. The Flux model outlasted the standard version by 50 kilometers of additional range, using the same battery pack. These weren't prototypes duct-taped together in a lab. These were production-ready motors, built with manufacturing feasibility in mind. Mercedes showed not only that the motor worked, but that it was ready to scale. This level of testing, validation, and transparency sent a clear message to the industry. The YASA Flux Motor isn't the future, it's the present, and anyone not ready for it is already behind. For over a decade, the electric vehicle industry has followed a familiar narrative. Tesla leads, BYD scales, and the rest follow in formation. But that narrative just got rewritten. With the unveiling of the YASA Flux Motor, Mercedes has transformed from a legacy luxury brand into a full-fledged tech disruptor. They've introduced a motor that isn't just evolutionary, it's revolutionary, one that changes the performance curve, the design blueprint, and the economics of electric mobility. Tesla and BYD are still giants, but for the first time, they look vulnerable. Automakers worldwide now face a stark choice: adapt or fall behind. Consumers, meanwhile, are about to experience electric cars that charge faster, drive longer, and perform better, all at potentially lower prices. And all of it started with a whisper in 2021, a quiet acquisition that no one paid attention to. Now, that whisper has become a roar. The next 5 years will define the winners and losers of the electric age. But make no mistake, Mercedes just made the first move, and it may be one that changes the industry forever. Stay tuned. This EV war is far from over. Once again, thanks for watching this video. If you got something out of this, hit that like button and make sure you're subscribed so you don't miss the next one. And hey, let me know your thoughts in the comments. Agree, disagree, or something in between? I'd love to hear it.